Hi guys, welcome you all to my channel Explore Edu to Teach.
So here we are with another video of digital electronics in which we are going to cover the topics like SOP, POS and K-map representation. This video is going to basically talk about the initial two topics, that is the SOP and POS. It's going to be a short video. Please understand this video very well because this is the prerequisite for K-map. K-map forms a very important part of digital electronics. In It helps you in reducing the Boolean expressions, the given functions. It's one of the most important tool. So in order to understand K-maps, you need to know SOP and POS. Hence, I'm going to explain those terms in this particular video. Please make a note of it. The notes are given down in the description box of this video. Download it from there. Do not forget to like, share, subscribe to my YouTube channel. Follow me on Instagram. Also on Instagram, I am regularly posting some formula sheets, regular updates of all the videos which are going to be put on my YouTube video, what is going to be the content of those videos so that you get updated regularly. So do not forget to subscribe to my YouTube channel, hit the bell icon so that you get notified every time a new video goes live. Also follow me on Instagram for all the regular updates and for all the study related notes. So let us begin with the SOP and the POS part for this particular video. So what is basically a product? Product indicates in digital electronics term and operation, and sum indicates or operation. So when I talk about SOP, SOP is nothing else than sum of product. So as the name suggests, it is going to be sum of products. That is, if I talk about sum, it corresponds to OR operation. Hence I'm writing ORing of product. Product indicates a AND operation. Hence of AND terms. So when I talk about SOP, SOP indicates sum of products, that is ORing of AND terms. I hope I'm very clear to you. Next, it is POS. POS is nothing else than product of sum. So product, as I told you, indicates AND operation. Sum indicates OR operation. So it's ANDing of OR terms. So this is just the technical language. We'll see the expression. You'll understand it better. But just remember that a product indicates a AND operation. Sum indicates a OR operation. So when I talk about SOP, it is basically sum means ORing and product means AND. Similarly, product means ANDing and sum means OR. So let us see how do we represent in the form of an equation and an expression. So as I told you, SOP is nothing else than sum of product or and or implementation. So what is happening is that we are having sum of product. So there have to be product terms like A, B, Y, Z. They are all product terms, right? AB is a product of A and B. YZ is a product of Y and Z. And they both are the OR operation or the sum operation. So when I talk about sum of product, it indicates the ORing of AND operations. That is the sum of product. So you have the inputs A and B, AB. You have the inputs Y and Z, that is YZ. The output is going to be AB plus YZ. So this is the logic gate implementation of this particular sum of product, that is ANDing of OR operation. I hope, okay, I'm sorry, it is ORing of AND operation. Okay, so what does SOP indicate? SOP is sum of product. So logically you can understand that it is going to be summation of all product terms. So AB is a product term, YZ is a product term, and it is a sum of those terms. So it's AB plus YZ is equal to F. AB is the product, YZ is a product, and AB plus YZ is the function. That is the SOP implementation. Now understand this term Minterms, because this Minterms, Maxterms are going to be very important for your K-map representation. So please understand this. So if I talk about SOP, SOP is related to Minterms. In Minterms, just to give you an idea, my bar, that is a particular variable which is being given with a bar, is represented by 0, and a particular variable which is not indicated with a bar is given as 1. So when I talk about SOP, SOP is nothing else than sum of products, and that is related to the Minterms, in which if I talk about A bar, B bar, C bar, it indicates 0, 0, 0. Hence, we have 0, 0, 0 is nothing else than 0. And A bar BC, it indicates 0, 1, 0. I told you any particular variable given with a bar is given as 0. Any particular variable not with a bar is given as 1. Hence, given 0, 1, 0, I have the value 0 and 2. Therefore, min terms are called as SOP. I hope I'm very clear to you. Similarly, you have product of sum, that is POS, or and implementation. I hope I'm getting very clear to you. So when I talk about product of sum, that is POS, or and implementation, what do I mean by this? Try to understand. So you have a function given as a plus b and x plus y, right? So when I talk about a plus b, it indicates the product of some terms. So a plus b is a sum term, x plus y is a sum term. It is just a product of it. Hence, it is called product of sum. In case of your SOP, we had sum of all the products. So A, B, Y, Z were products. You are doing a sum of it. Here you have the product of sum. That is A plus B, X plus Y are all sum. And this is a product of it. Hence, you have A plus B, X plus Y. And you have the A plus B into X plus Y. Next, your product of sum is been indicated with max term. As I told you, in case of your SOP, SOP is indicated with min terms. Your product of sum is given with max term, in which my bar variable is given as 1 and non-bar variable is given as 0. So if you see over here, in case of min terms, my bar variable were indicated with 0 and my non-bar variable were indicated with 1. So it is simply the opposite over here, wherein my bar variable is given as 1 and non-bar is given as 0. So a plus b plus c will be given as 0, 0, 0, and a plus b bar, it should be c over here. Okay, it is c, not c bar. It's a mistake over here. Please make the correction. I'm sorry for this name. It should be a plus b bar plus c. In that case, it is 0, 1, 0. Understood? Therefore, it is given as capital M0 and capital M2, and the representation in terms of pi. If you see in terms of your min terms, the representation was in terms of summation. Whereas in case of your max term, it's written in terms of your pi, which is 0 and 2. Max terms are also called as POS. So next class will be dealing with K-maps. So for this particular concept is very important. Although you might feel it's a very basic kind of concept, but understand it very well, because this will only help you to move forward in K-map. Because in K-maps, you will hear terms like min terms, max terms. If you have confusion in that, then solving K-maps will be difficult. Hence, I've taken a separate video on it. I'll just give you a summary about it. So basically, sum of products indicates sum is ORing, product means and. Similarly, product is ANDing, sum is OR. Now you have a SOP. SOP means sum of product terms. This is a product, this is a product, and we are doing a sum of it. SOP is also indicated in terms of min terms also. Hence, I have SOP associated with min terms, in which my bar variables is given as 0 and non-bar variable is given as 1, and try to find out the answer. Min terms is given as summation, and hence min term is called SOP. Then you have product of sum. In this, what happens is that it is basically the product of some variable, that is a plus b is a sum, a plus or a or b is sum, and then you're doing a product of it. It's going to be associated with max terms. So what happens in max term is that your non-bar variable is given as 0 and your bar variable is given as 1. Hence you have 0, 0, 0 and 0, 1, 0. This should not be C bar, this should be C. And just try to find out 0 and 2, and max term is given as this pi variable, whereas your min terms is given as summation variable. And that's it. So we have this kind of representation in SOP and POS. If you like the video, do not forget to like, share, subscribe to my YouTube channel, share it to as many people you feel can get benefited out of it. Follow me on Instagram. The links are given down in the description box. Also, please wait for the next lecture also, because this is a continuation for K-map and all those things. There will be solving of sums on K-map also. It's very useful for your university exams, for your other exams. K-map plays a very important role. in digital electronics. So please do not forget to like, share, subscribe to my YouTube channel. Follow me on Instagram. Thank you so much, guys. God bless you.